Okay, so what we're going to be working on is graphing log equations, okay, and talking about some key features, just like we've been doing for all the other equations that we've graphed and looked at. We did shifts and not asymptotes, but intercepts and stuff like that, domain, range. We have to do the same thing for our log graphs. All right, so remember, just a quick review here, that a log is the inverse of the exponential. So when I have this, y equals 2 to the x power, and its graph looks like this. Remember, it went through 0, 1, and it looked a little like this. And my x-axis here was my asymptote, which meant the graph got closer and closer to the x-axis, but didn't cross the x-axis. So that's my exponential. And then what we did was we took this exponential and we flipped it over the line y equals x. That's my inverse, which means xy becomes yx. All right, so we switch x and y and we got x is equal to 2 to the y power. And when I flip it over the line, then it goes through 1, 0, and it looks like this. And now notice the graph. Now it actually goes through the x-axis. The x-axis is not my asymptote. Instead of having a horizontal asymptote, it has a vertical asymptote. And the asymptote is my y-axis in this case. So remember, we don't like to have things in x equals form, and that's where logs came from. So this was y equals log base 2 of x. All right, so now what we're going to do is we're going to start shifting things, the log equation, back and forth, just like we did with the exponential. Right, we move this up, down, left, right, so that meant the asymptote, the horizontal asymptote moved up, it moved down. So now I have to do the same thing with my log. So now, since it has a vertical asymptote, and this asymptote is x equals 0, we're going to now start moving this left and right and up and down. All right, so what's going to move then is this vertical asymptote is now going to start moving up and down to the left and up and down to the right. So my asymptote, my vertical asymptotes are going to always be x equals. Remember, horizontal asymptotes are y equals for your exponential. In this case, your logs are going to be x equals. All right, so let's take a look at what we have over here on our video worksheet. All right, so notice my equation up here. It says f of x, remember that's your y equals, log x, that remember if there's no base written, it's really base 10. And when you have a log of base e, that's your ln x, because this is all true for ln 2. So this says to, and this is going to be, it's nothing new. It's just, doing stuff now with logs. It's kind of like review. It's just taking everything that we know and kind of putting it with logs now. We're going to do domain. Domain, remember all your x values. We're going to do the asymptote. It's a vertical asymptote, though, not a horizontal asymptote. The intercepts, the x-intercept, y-intercept. And we're going to sketch it. You can use your calculator to sketch it, but I want you to sketch it on the graph too. So we're taking a look at f of x is equal to log x, which is actually base 10. Right, so this is actually y equals log base 10 of x. All right, so you could graph it in the calculator if you would like. When you graph it in your calculator, you just have to type in y equals, go to y equals log, and just type in x because your calculator, remember, does base 10. So hit graph, and you could take a look that you graph. Look at the points. You have a 1, 0 and a 10, 1. So it goes through 1, 0 and 10, 1, which is over here. And my asymptote, I want you to draw in the asymptote for me. Okay, I didn't have you guys drawing in the asymptotes for the exponentials, but I think it's going to be a good idea because when you guys took that test and you had to graph the exponential, some of you guys were on the asymptote, you went over the asymptote, so I want you guys to draw in the asymptote. Here is your asymptote. This is the y-axis. It's not going past the y-axis in this case. All right, so you can't go past it. So this is what my log looks like, this. Okay, so now I want to know, what is my domain? My domain, okay, actually the asymptote, let's do the asymptote first. My asymptote here is x is equal to 0. So let's write that down, x is equal to 0. So my domain, my x values are everything from my asymptote to the right of my asymptote. So my domain is x is greater than 0. So your domain is always your asymptote, but greater than that. All right, your x-intercept. So I'm going to do this on the bottom over here. X-intercept. X-intercept, remember your y value is equal to 0. You can get it from the graphing calculator. So this is the x-intercept, it's 1, 0. Sometimes, though, you're going to have to be careful because what if it's a decimal? So you have to be able to do this algebraically. And this is easy. This is not too hard to do. So remember, this is my equation. Y is equal to log base 10 of x. Base 10 of x. My y is 0 equals log base 10 of x. I'm going to put this in exponential form, so it's 10 to the 0 power is equal to x, so x is equal to 1. So my x-intercept is 1, 0, and it needs to be represented as a point, not just a number. All right, now let's do our y-intercept. Now, is there a y-intercept? If it just keeps getting closer and closer to the y-axis, that's my asymptote, there's not going to be a y-intercept. And I just want you to see, and sometimes there will, depends on if there's a shift. If there's a shift to the left, there will be a y-intercept. But just take a look at this. To find the y-intercept, your x is equal to 0. So I'm doing y is equal to log base 10 of x. So I have y equals log base 10 of 0. That you could just plug into your calculator, right? I showed you guys how to do that. You could do the change of base. You could do the change of base, or you could. There's that that button that you could use in there in the math. And notice that you get an I in there. That's that imaginary number. That means there is no y-intercept. Okay, so now let's talk about the shift. Remember, to shift something left, to shift something left and right, you need to change the x value. All right? Is there anything added or subtracted from the x value? No. So there is no shift. There is no vertical shift or horizontal shift. So the vertical shift would be adding something to the y value up and down. This is your y value. It would have to be on the outside. And there is no horizontal shift or vertical shift. So this is none and none. All right, so now let's take a look at the bottom. I'm just going to move all this up. All right, so it says find the domain and the asymptote. So let's first start with the asymptote. You have to identify that there is a shift here because this is a -2, right? Okay, so I have this shift here of -2, which means it's minusing 2 from the x value. That means it's shifting it to the right by 2. So that means my asymptote is x is equal to 2. Which means it's not going to go past 2. So if you had looked at a graph, your asymptote would be right here at x equals 2. So your graph would look like this. It's not going to go past 2. X is equal to 2. So your domain is x is greater than 2. All right, so let's take a look at number 3. My shift is +5. That means it's moving to the left 5. That means my asymptote is x is equal to -5 because it's going to the left 5. So on a graph over here at -5, here's your asymptote, and your graph would look like this. Your graph would look like, sorry, I hit the iPad. It would look like this, okay? And so that means my domain would be x is greater than -5. All right, and the last one here, My shift is -1. That means it's to the right 1. That means my asymptote is x is equal to 1 because it's going to the right 1. And that means then my domain is x is greater than 1. Okay, so let's take a look at the flip side. So flip your paper over. Okay, so let's talk about the transformation rules really quickly again. All right, so when we shift, when we have a vertical shift, that's the up and down. That's being, remember, that's being added to the y value. This is your y value, so I have a plus b. Horizontal shift would be adding it or subtracting it just from the x value. Remember, it goes opposite the way you think it goes. Reflection over the x-axis, your y value changes. Remember, this is y, your log. So that changes to its opposite. And a reflection over the y-axis, x changes to its opposite. That's why it's inside the parentheses, just to the x value. All right, so what we want to do here is just quickly identify the transformation. I'm starting off with my log base 4 of x. What's my transformation? If I change x to its opposite, that means it's a reflection over the y-axis. Reflect over the y-axis, x changes. I have a +2 on the outside of the parentheses. That means I'm moving it up and down. That's up 2 in this case because you're adding it to the y value. All right, number 2. Here's my equation, log base 3 of x. Notice I have the negative to my y value. That means it's a reflection over the x-axis. And I have a -4 to my whole equation. That means it's down 4. And the last one, my log is log base 5 of x. And notice it's negative to the log. That's to my y value, so it's a reflection over the x-axis again. And I have a +7 to my x. That means I'm moving it along the x-axis. It goes opposite the way you think it goes, so it does not go to the right 7. It goes to the left by 7. Okay, so that's it, and we'll practice some more tomorrow in class. Have a good night, everyone.